So first of all, hello everyone, and welcome to our third Continuum Town Hall. My name is Liz Walls, and I'm the lead developer of the Continuum Wind Energy software. And joining me is Erin, the product manager of Continuum. I see quite a few familiar names here today, as well as some new ones. So welcome to all of you. Thank you so much for taking time out of your day to join us. We're really glad to have you all here. So with that, let's just jump right in. I'll turn it over to Erin, who will discuss the agenda for today's town hall.
Yeah, thanks, Liz.
There we go.
Sorry. So yeah, I'm not going to be doing a whole lot of talking today. I'm fighting off a cold, so I've got some congestion going on. So Liz is going to be taking over the reins for the most part. But we do want to kind of let you in on some of the new features that are going to be coming out with the new release of 1.3.2. It'll be coming out here shortly. Hasn't been released yet, but just kind of give you a little heads up preview of what's to come. And then kind of the bulk of today's town hall is the first part of our lecture series, the Continuum Wind Flow Model Explained. So we're going to get into kind of the building block of the continuum model, which is terrain exposure, kind of diving into it and what is it, how do you calculate it, and getting into the nitty gritty of that. And then just a real quick recap reminder for our continuum contributors, and then we'll kind of top it all off with some Q&A, any open forum questions you guys have about the model in general, and we can go from there. So thanks for joining us today. Really, this is going to be a great lecture series that we are really excited to present to you guys to give you a little bit more in-depth knowledge of the continuum model. And Liz is going to take it away.
All right, thank you, Erin. And yes, there was a bit of echoing back and forth. Normally, Erin and I work from different locations. Erin's based in Florida. I'm in Washington State. We're actually both in Findlay, Ohio today at the One Power Company's headquarters. So every quarter we come to Ohio to work together with our team. So we're in person today working together. So let's jump right in. So as Erin mentioned, we have a new version of Continuum that is in the works. I was hoping to have it ready for today's town hall, but didn't quite get there. But at the very least, wanted to give you a preview of some of the new features and updates that will be available in this next release. So first of all, one thing that we'll be adding is a new release update. So in this next version of Continuum, once it's installed, and if there is a new release that comes out and is available, now when you open the software, a little text box will appear and let you know, hey, there's a new release available that you can download and install. So a more efficient way to communicate the new releases to our users. Next, we added a new export in the long-term reference module. So now on this tab, when you download, say, Mira 2 or Era 5 data, you can export it as a time series, but now you can also export it as a tab file, which I found has been useful for different modeling activities that I've done. Next, I had to fix an issue with the map generation. So in the last release, 1.3.1, I added parallel threading in an effort to speed up how the maps were generated. But it turns out that in parallel threading, this was affecting the writing and reading to the database. For those of you who are not aware or didn't realize, Continuum actually works in conjunction with a local SQL database, which is used to store topography data, calculated exposure values, and other parameters that are used in the modeling. And what was happening in the parallel threading is that there were times where the software would be writing to the database at the same time that a different thread was trying to access that same database entry. So it caused some cross-threading errors, and so we're fixing that in the next release. We've also added a new option in the download topography tool. So now you can download USGS 10-meter data. So finer resolution topography data just available in the US, but wanted to mention that is also now available. And then lastly, we're incorporating a new built-in land cover key. A land cover key is what is used to convert land cover types into surface roughness and displacement heights, which are used in the wind flow model. Up until now, we've had built-in land cover keys for the US National Land Cover Database, as well as the European CORIN land cover data. But South Africa also has a different type of categorizing their land cover data, and a Continuum user, Ashlyn Naidu, who was highlighted in the last town hall, he was gracious enough to share the land cover key that he created for his modeling. So that will be a new built-in key for, I know there are several folks here from South Africa that should be helpful in your wind flow modeling. Okay, so those are the new features in 1.3.2. So keep an eye out for the new release. I'll be posting it on the website when it's available, as well as on LinkedIn, and I'll send an email to all the folks here on the town hall to let you know when this new release is available. Okay, so now let's jump into the main part of today's town hall. This is part 1 of a 6-part lecture series, which we're calling Continuum Explained, a wind flow model lecture series. So let's talk a little bit about this lecture series and what we'll be covering today. So first of all, what I'm displaying here is the full equation for the continuum wind flow model. I'm not going to go over all the parameters right now, just wanted to give you a snapshot of what that looks like. And so we'll be exploring each of these different components step by step throughout the 6-part series that we'll be giving over the next year. So the first couple sessions, including today, will be focused on understanding the upwind and downwind terrain exposure components, which are highlighted. It's the first 2 components of the equation. Session 1 today will be focused just on the definition of exposure. What is it? How is it calculated? And what does it mean? And then in the next session, we'll dive in more understanding how different terrain exposures translate into different flow types and what that means. In session 3, we'll switch gears and we'll talk about the surface roughness component of the model, which is highlighted here. This is based on a modified version of the log law, and it estimates the change in wind speed due to changes in the surface roughness and displacement height. Session 4 will cover the newly added elevation and valley flow components, which were added just last fall to the wind flow model. So that will be session 4. Session 5 will get into terrain complexity, how terrain complexity is quantified in Continuum, and how it is used to define the model coefficients in the model. And then the last session, session 6, is where we will go over the machine learning algorithm, which is used to find these model coefficients, which yield the lowest met cross prediction error. So that's a snapshot of what to expect over the next year. We'll be doing these lectures every 2 months. And so, yeah, so today we'll be talking about terrain exposure. So let's jump right in. So in explaining terrain exposure, we thought it would be helpful to have some example wind farms to include to talk about the exposure at different wind farms to understand what we're talking about. So we selected 3 different wind farms to use an example in this lecture, one with a low, one with a moderate, and one with a high level of complexity. And here's the location of those 3 wind farms. They're all in the US. The site with low complexity is Kingfisher Wind. This is located in Oklahoma, pretty flat site with low terrain complexity. Then we have Western Spirit in New Mexico. This is a moderately complex site. And then up in Pennsylvania, we have a highly complex site, Allegheny Ridge. Taking a closer look at each of these sites. So here we have the topography map for Allegheny Ridge. This is the highly complex site in Pennsylvania. The red dots are showing the turbine locations, which are along this ridgeline, a pretty steep ridgeline in Pennsylvania. Yes, certainly you can have the whole PowerPoint at the end of the session. Fantastic idea. And then next we have a topography map of Western Spirit. So this is the moderately complex site. It has rolling hills as well as generally downward sloping terrain in the prevailing wind direction, and it's considered to be moderately complex. And lastly, we have Kingfisher Wind. This is in Oklahoma, as I mentioned, quite flat, low complexity, simple terrain at this site. So 3 different wind farms, different levels of complexity will help us to explain better exposure and how those values vary. Okay, so now what is terrain exposure? What is the definition of this term? Well, here it is. So the definition of exposure is the average elevation difference between a site and the surrounding terrain within a specified radius weighted by the inverse distance. That may seem like a lot of words, but it's really, not that complicated. It's here's the equation shown here. Again, it's the elevation difference weighted by the inverse distance. Now, this concept of terrain exposure was originally introduced by Jack Klein, who I believe, yes, Jack is attending our town hall. Hey there, Jack. Great to see you. Thanks for joining us today. And it was Jack who came up with this concept and found that exposure lent to a pretty effective way of modeling wind flow. So thank you, Jack, for that contribution. So now let's explore how exposure is calculated. So in this equation, you'll see there's a subscript theta, and that is implying that we're actually calculating the exposure on a sector-wise basis. So the topography map I'm showing here is from Allegheny Ridge, that complex site in Pennsylvania. And the black dot is the representative turbine location that we'll be looking at in all these different examples. So the way exposure is calculated, again, it's on a sector-wise basis. So in this example, we have 12 wind direction bins with a 30-degree width. And so the way that it would work is it would go sector by sector and calculate the exposure in each of those sectors. Now, one really important concept that we want to make sure everyone is comfortable with and understands is that the exposure has both an upwind and downwind component to it. So let's explore what that means a little bit more in a very specific example. So again, this is the Allegheny Ridge site topography map. And let's say we're considering just the northerly wind direction sector, so wind direction of 0 degrees. So when looking at the wind from the north, again, from 0 degrees, the upwind sector is 0 degrees. So the upwind sector is the north. And in this example, the upwind exposure in this sector is 54.3 meters. So on average, the site of interest, the turbine, the representative turbine, is approximately 54 meters higher than the terrain in the north. Meanwhile, the downwind sector is in the opposite direction, is 180 degrees from that, so it's from the south. So when considering, again, the wind from the north, upwind exposure is the north sector, and the downwind sector is from the south, so offset by 180 degrees. In this sector, for this example, the downwind exposure is 128.2, so approximately 128 meters higher than the terrain in that downwind sector when considering northerly flow. So we can move all along the wind rows and continue the example. So when considering the wind from the north-northeast from 30-degree wind direction bin, the upwind sector is that 30-degree bin, in this example with an exposure of approximately 22 meters. Meanwhile, the downwind sector is offset by 180, so just on the other side of the wind rows, and the downwind exposure in that sector is 60.9. So we can march around the wind rows all the way now to 180 degrees. And so now, when considering the wind from the south, from the wind direction of 180 degrees, the upwind sector is from the south, and the upwind exposure is 128.2 meters, which, and this is important, this is the same downwind exposure when considering the wind from the north. So it's just equal and opposite, just in the other direction. And similarly, the downwind sector, when considering wind from the south, the downwind sector is the northerly sector with an average elevation difference of about 54 meters. So that's an important concept to understand. Again, the exposure is calculated in each sector, and each sector has a corresponding downwind sector, which is offset by 180 degrees. So we're going to continue marching around 210. The downwind sector is 30 degrees, and the upwind and downwind exposures are the opposite from the north-northeast. Okay, so that was the sector-wise exposures, but we also calculate the overall exposure. The overall exposure kind of condenses all the sector-wise values into a single value, and it can be helpful for just considering, the complexity at a site or comparing one site to another. So it's a helpful parameter. So we want to explain a little bit about how the overall exposure is calculated. So it is simply the exposure in each sector weighted by the wind rows at that site. So for the overall upwind exposure, it is the exposure in that sector multiplied by the wind rows, and for the downwind, it is the downwind exposure, so offset by 180 degrees multiplied by the wind rows. We're going to go through the same example just to make sure that people are understanding what that means. So when calculating the overall upwind and downwind exposure, we're just going to go sector by sector. In this example, again, this is from Allegheny Ridge. So we saw a 54-meter upwind exposure, 128-meter downwind exposure, and the wind rose frequency for the northerly component is 3.3%. So for the overall upwind exposure, you'd multiply the upwind exposure by the wind rose frequency, and then for the downwind overall exposure, multiply the downwind exposure by the wind rose frequency. And then that continues along each wind direction sector, moving around the wind rose, doing this weighted average to come up with the overall upwind and the overall downwind exposure. Okay, so that covers the concept of upwind and downwind exposure. Now let's get into some of the math. How is the sector exposure actually calculated? So here we have the equation again, and to help explain, this is a plot showing the elevation on the y-axis, distance on the x, and this is actual terrain data from the Allegheny Ridge site in the prevailing direction, which is 300 degrees, or from the northwest. And so everything on the left-hand side of the midpoint is the upwind direction sector. So this is all the 300-degree wind direction sector, and everything on the right-hand side, that is the terrain on the downwind. So on the other side, 180 degrees from the prevailing wind direction. At the center line, this is where our site of interest is. So this is the elevation at the representative turbine that we're measuring the exposure at, and that is Z0. So that is the elevation at the site of interest. And then ZI is the elevation at each data point within this radius in either the upwind or downwind direction. So we have many of these data points, and it's a summation of all those data points included in that radius. And then the distance sub Z0 minus ZI is simply the distance from the site of interest to each of those grid points within the radius. And then finally, in this example, we're showing a radius of investigation of 6,000 meters. So by changing that radius, we'll obviously change, how many data points you're including in the calculation. So that's an overview of all those parameters. And then also we have beta here. This is the inverse distance weighting. So let's talk a little more about what that exponent does. So just repeating the definition of terrain exposure, highlighting that it's weighted by this inverse distance. Here's the equation, and then it's beta that we'll be modifying here as the exponent. And so by changing beta, this affects how quickly the influence of each data point Zi, how that diminishes with distance. So by increasing the exponent above a value of 1, we'll place higher weighting on terrain closer to the site and less weight on terrain further away. So let's take a look at how modifying this exponent changes the terrain exposure. So here is the calculated sector-wise exposures for the Allegheny Ridge site, which is the highly complex site in Pennsylvania. So this plot is showing exposure on the y-axis versus wind direction on the x. So it's a sector-wise plot on an xy. Now with an exponent of 1, you can see the terrain variation clearly. You can see that the exposure from the east at a 90-degree sector is, around 150 meters. And then on the other side of the wind rose around 202, 225 degrees, the exposure drops quite a bit to 80. But as you increase the exponent from 1 to 2, you see the same general trend, but it's muted. You don't see the variation in the terrain exposure in a sector-wise basis as much when you increase that weighting, because again, it's placing a lot of weight on the terrain close to the site. And even further, when you increase it to 3, the trend in the variation of the exposure is really muted compared to with an exponent of 1. Here are the results from that moderately complex site, Western Spirit in New Mexico. And we're seeing a similar thing. And this is an interesting site. So now we have positive exposure from like 120 degrees. And then we have negative exposure from westerly flow around 270 degrees. So a negative exposure means that the terrain in that direction sector is generally higher than your site of interest. So at Western Spirit, the terrain generally slopes down. So that's what that negative exposure means. It means that the terrain is higher than where you are. But again, as you increase the exponent from 1 to 2 to 3, you're not that the trend in the terrain gets muted and less pronounced, again, because the terrain closer to the site is being weighted so heavily. And then lastly, this is the results from the low complexity site, Kingfisher, and we're seeing a similar thing. We're seeing when you have an exponent of 1, it's clear the variation in the terrain exposure, the trend is a lot more pronounced and a lot more obvious. And when you increase the exponent, it becomes a lot more subtle. So that is how the inverse distance weighting affects the calculated exposure. Let's now move on to the radius of investigation. So as part of the definition of exposure, it's within a specified R. So let's look at how that affects the calculated values. So as I mentioned, right, if you increase that radius, you're going to include more data points in that sector in this calculation, in the summation. So here are the results from the Allegheny Ridge site. We were varying the radius investigation from 4,000 to 6,000, 8,000, and 10,000 meters, so 4 different settings. And we can see that generally the trends are very similar using the 4 different radii, but the magnitude using the higher radius is greater than the others. But generally, we're seeing the same trend increasing, decreasing as you move along the wind direction sector or move along the wind rows. Next, here are the results for Western Spirit. By changing the radius investigation, you still see that positive exposure from 120 degrees and the negative exposure from the west 270 degrees. But again, with a higher radius investigation, the magnitude of the exposure is higher than with the lower radius. And then lastly, we have the low complexity site, Kingfisher, and similar observations. Trends are generally consistent using different radius, but the magnitudes are higher when you use a larger radius investigation to calculate the exposure. Okay, so now let's check out how the resolution of your elevation data is going to affect the exposure value. So elevation data is available with different grid resolution. Typically 10, 30, and 90 meters is a typical range or different elevation data resolutions that are out there. So let's take a look at how that affects the calculated value. So with a finer resolution with 10 meters, you're going to have a lot more data points, right? With 90 meter resolution, you'll have a lot fewer. But let's see how that affects the overall calculated value. And it turns out it doesn't make that much of a difference. So this is the results from Allegheny Ridge. Again, exposure on the Y, wind direction on the X. And we're showing the results using 10 meter, 30 meter, and 90 meter resolution for our topography or elevation data. And as you can see, there's small differences when you use, this is the 90 meter, there's some slight differences there, but generally they're very consistent. This is the results from Western Spirit. The 10 and 30 meter exposure values are nearly identical. There's some deviation when using the 90 meter direction sector or 90 meter resolution data, but a pretty small difference overall. And when looking at Kingfisher, this is the low complexity site. There is essentially no difference when using 10, 30, or 90 meter. And to be honest, this surprised me a little bit. And when we did the sensitivity analysis, I was expecting the results from the 90 meter resolution data to be more to be different, to show some variability. But it was interesting that it's pretty insensitive to the resolution of your elevation data. All right, next let's talk about the wind direction bin size. Going back to this equation, so the number of wind direction bins will determine the width, right, of the sectors that you're using, and that will affect how many data points are included and how many sectors to use overall. In the example, we showed an example using 12 wind direction bins, but what we did a sensitivity using a range of wind direction bin sizes from 4 up to 16. So let's take a look at how the sector-wise exposures vary using these different wind direction bins. So if we have just 4, wind direction bins, right? So northeast, south, and west, just 4 of them. These are the calculated sector-wise exposure values. So obviously, if you only have 4 bins, it's going to be quite coarse. You're not going to see a whole lot of the detail in terms of what's happening at the terrain surrounding that site. If you increase the wind direction bin size up to 8, then you start to see more variability, start to see more of what's happening at that site. At Western Spirit, for example, you can start to see more clearly that there is a positive and then a negative exposure at that site. And at Allegheny Ridge, you're starting to see the highly complex and largely varying terrain as you go around the windrows. Next, let's go up to 12 wind direction sectors. So now we're seeing more and more detail, finer resolution, can see more clearly what's happening at the site. And then lastly, obviously, as you move it up to 16, you're chopping it up into finer chunks, calculating the exposure, and you're able to see with better resolution what the terrain looks like in terms of exposure on a sector-wise basis. Okay, so those are the different sensitivities that we ran to explore how these different parameters in the exposure calculation affect the overall calculated value. Let's take a quick step back, though, and revisit the radius of investigation. So in these results, we showed the calculated exposure value using 4 different radii. And that when it changes the calculated value. But you might be asking yourself, well, okay, but which radius investigation should we use? And that's a great question to ask. And what we found in our experience is that at one site, when doing a wind flow model, you might get really good results using a radius investigation of 4,000 meters. Whereas at a different site, you might get really good results using a radius of 10,000 meters. From my experience, the best model is usually between those radii. But when creating the continuum model, one of the main ideas was that this was supposed to, or should be, a universal model that would be applied consistently from site to site without having to pick and choose which radius investigation to use at each location. So what we do in Continuum is there are actually 4 separate individual wind flow models that are created. And they each use 4 different radii. Specifically, they use these 4,000, 6,000, 8,000, and 10,000 meters. One of the ideas was, again, we wanted it to be a universal model that was applied consistently. And also in this approach, it generates multiple estimates. And those multiple estimates are then combined in an ensemble type approach, which has been shown to help reduce wind flow error or modeling error. We'll talk more in more detail about how these estimates are combined to form the overall estimate, but it is an important thing to keep in mind, again, that there are 4 separate independent models that are created in Continuum using these 4 different radii. Okay, so now let's talk a little bit more about the parameters that we explored in the sensitivity and what settings are in Continuum that are hard-coded, parameters that cannot be changed by the user, and we'll talk about the parameters that can be modified by the user that are user-defined. So first of all, as I mentioned, we have these 4 separate models, and that is hard-coded. That's not something that a user can change. That is something that is in the software. Well, I should say, if you download the source code, you can change it yourself. But if you're using the compiled version executable, then those are the radii that are used. Also, we use an inverse distance weighting of 1, right? As we showed in the sensitivity analysis, when you increase that exponent to something greater than 1, then it really mutes the trend in the calculated terrain exposure. You don't see the variability because it places so much weight on the terrain close to the site of interest. So we found that by keeping the inverse distance weighting at 1 is the best way to capture the terrain variability and results in the best wind flow model. Now for the parameters that the user can change. So those are 2 things that the user can control. The first one is the elevation data resolution. You import the topography data, so whatever data you're importing, you determine what that data resolution is. We typically use a 30-meter grid resolution, but from the sensitivity, we actually showed that using 90 meters resulted in essentially the same values, which I thought was, again, I was a little surprised at that. But we generally use 30 meters. We don't typically recommend using the 10-meter data because computations take longer with really minimal benefit to having that extra resolution in terms of, finding the overall terrain exposure. Next, the wind direction bin number. The way that a user can change what this is through either the tab file that you're importing. So the number of wind direction bins in the tab file will determine the number of wind direction bins used in the wind flow model if you're using tab files. If you're using time series data, then there's a drop down in Continuum that specifies the wind direction bin number, so you can modify that from 4 up to 16. We recommend a minimum of 12 direction sectors. If you use fewer than 12, then you're not fully capturing the variability on a sector-wise basis. We don't recommend going lower than 12. And so those are the recommended settings and what users can modify. Okay, so now I wanted to talk a little bit about the software and how users can examine and export exposure values at the MET sites as well as the turbine locations. So I'm showing a screenshot here of the turbine or the MET and turbine summary tab in Continuum. And once you have imported your topography data, your MET tower data, turbine locations, and then calculate the exposure of the turbine values, this will populate. And so what we're looking at here, first of all, this table will show the list of all the MET towers and turbine sites that you've imported into the software. Then we have the elevation at each of those locations. Then we have the wind speed at the MET tower. It's the measured or the actual wind speed that the data import says. And then also we have the estimated wind speeds at each of the turbine locations. We also have the Weibull scale and shape parameters listed. And we'll go over all this once we get to the actual wind flow modeling part of it. But what I really wanted to highlight here is that you can view and compare the overall upwind and downwind exposure at all the sites. So you can scroll through that table, and then the plots here are showing the relationship between the wind speed and the upwind exposure, the wind speed and the downwind exposure, the wind speed and the difference between the upwind and downwind, and then the wind speed as a function of elevation. So by default, when you go to this tab initially, it will have the radius of 4,000 meters selected, but you can pull down this dropdown and view the exposure value at any of the different radii from 4 to 6 to 8 to 10,000 meters. So that's how you view the exposure in different radii. Also, by default, it will select overall for the wind direction sector, which shows the overall exposure that we talked about, which is the sector-wise exposures weighted by the wind rows. But you can pull down this drop-down menu to any of the wind direction sectors to view and inspect the exposures on a sector-wise basis. And then if you click this button, Export Values, then it will open up this dialog that allows you to export either the sector-wise and the bulk or overall. It's the same thing, bulk or overall, upwind and downwind exposure. Or you can select just to export the sector-wise or just the bulk ones, which radius investigations to include. You can specify, all the turbine locations or just a specific one, and then it will export to a nicely formatted CSV. So I use this all the time when I'm looking at a new site. This is one of the very first things that I'll go to look at. It is a really good way to get familiar with your site, to understand what the terrain looks like in terms of complexity. As we'll talk about the next session, is also indicative of what kind of flow type you're looking at in terms of uphill or downhill or valley flow. So this is a really helpful tab. And so I encourage you to explore it, to get to know your sites in terms of exposure, and you can learn a whole lot about the wind farm that you're developing, as well as looking at where you sited your turbines, to look at what are the exposure values at the turbine sites compared to the MET sites. So there's a whole lot that you can learn from this tab. Again, I encourage you to explore it and see what you can learn about your site. All right, well, that concludes our very first lecture. This is part 1, again, of a part 6, or of a 6-part lecture series. Before we get on to the next part of the town hall, though, I did want to pause and see if there are any questions on terrain exposure in general, or any comments or anything at all that maybe wasn't clear. In the chat, Hello. Yep.
Yeah, so actually, currently I'm working in Acme Group, and that is an India-based IPP. So
Mhm.
actually, my team have downloaded this Continuum software, and we are using WindPro, WindFarmer, OpenWind. So this found us little bit difficult to use. So we tried to connect Continuum team as well, and my team also tried to reach you out in mail and LinkedIn, but not able to connect. So just also want to know, like, how can we connect with you guys?
Oh, so you're saying that you have some specific questions or some difficulties getting the software or to use the software? Is
Yes.
that what yeah. Um, well, I'd be happy to set up a call. We've done this with other continuing users. We'll have one-on-one consultation to help explain things further. May I ask if you've checked out the user tutorials? There's a series of PDF tutorials as well as some video tutorials to help new users. Have you checked that out? Oh, did we lose him?
First thing that to import the data and to start using this from that level we are facing. So if we just get a very brief idea of how to import data and start cleaning processing, then we will be able to use the software.
Yep, great. So I'll send you a link to those tutorials. There's a tutorial that walks you through how to import data, how to do the metadata QC. Really, they're tutorials that, I mean, we built them to cover, all the different modules within the software. So I'll share that with you after this call. And if you have further questions, uh, you can email me. And if email doesn't work, we can set up a call and I'd be more than happy to answer any questions you might have.
One more thing, like if my company wants to collaborate with you for distribution and of this Continuum in India, that also we would like to have a call for that as well.
Okay, great. Yes, let's connect after the town hall. Thank you for attending and your interest in the software. And I'd be happy
Yeah,
to
so
connect more.
actually, my reason of joining this is that only because I also tried to connect with you for this purpose
I totally
on
recommend that you
LinkedIn.
apply. Go online, leadershipacademy.org. You will see the application there. Also, you will. Oh, sorry. I think that was maybe a different call there. But yeah, so
Yeah.
maybe we'll allow some other folks to chime in, but um, we'll connect after this call and make sure that you guys have what you need to get going. Okay.
Yeah, yeah.
Okay, great. Thanks again for being here. I know that, yeah, a
Thank
few folks in India are using the software, so definitely more than willing to help out with any sort of difficulties you might be facing. Luis, did you have a comment, or I see you're unmuted there? Luis Ordenes? Ordenes? No, sorry. Okay, no problem. No problem. Okay, you're muted now. Okay, so yes, as I mentioned in the next session, we'll be exploring the next step of the wind flow model, getting into flow types, getting into a bit of the derivation of the wind flow model equation, deriving it from a simplified analysis of the Navier-Stokes equation of motion. So we're looking forward to that. And we'll open the floor up for some more Q&A. So if there aren't any more at this time, I'll turn it over to Erin to do a quick update on Continuum contributors. Second.
Yeah, so I think the big thing from today's lecture was we just want to really make sure that everyone's understanding this idea of what terrain exposure is, and that it's not just like it is a single number, but you're looking at the variation of the terrain in sector-wise pieces, and depending on a bunch of different parameters, you're deciding how many pieces of information are you including into your equation when you're calculating out that exposure. And the exposure, again, is kind of that basic foundation, the basic building block of the continuum model. Everything kind of just starts building on top of it. So if you, we'll send out these slides later on so you guys can review them. I know like this can, it's a little bit to chew. You gotta, really think about it. There's some tough concepts to really wrap your head around. But as you're going through these slides and kind of really digesting everything, if you have any questions, again, do not hesitate to email Liz or I, and we're super happy to kind of try to explain things a little bit different to see if it might resonate in a different way. But again, this terrain exposure concept is the building block. So really take some time if you want to understand the full continuum model to really grasp this concept of terrain exposure. So again, any questions, just email us and we'll be happy to either hop on a call or reply in an email. Happy to explain and teach and kind of further the knowledge of what this model can do. So kind of we wanted to reiterate our continuum contributor project method, whatever. So a contributor, it's someone, this is a community project. We want this model to be actively used and edited and enhanced by our community, by our continuum community. So by having these continuum contributors, you guys actively participating and getting your hands dirty and getting into the code and doing the studies and bettering this model. We would love for everyone to be able to be a part of this. So we have this concept of continuum contributor, where we're trying to just kind of push the industry forward. And there's a couple different ways that you can be a part of it, kind of just reiterating that. We've got a whole bunch of things that Liz and I want to get to add in to our into the continuum model. But there's always other things. If you're going through the model and you have other ideas of how to make this a little bit different, or hey, maybe this algorithm might be a little better this way, feel free. This is a living, breathing source code, and we want it to be very community based. So if you want to be a continuum contributor, please head over to that website, continuumwind.com/contributors. And that's where you can kind of get in touch with Liz and I in terms of this continuum contributor site and say, hey, I'm interested in helping out this section, or hey, I think it'd be really good to do this, but I don't necessarily want to do it. So, but just kind of throwing out the list of ideas. So check out that website and we can kind of grow this community and grow the model.
Great, thanks, Erin. And just wanted to add just a couple more things that we have a list that we are always reviewing and updating for open projects. And did you mention the software development versus R&D? Yeah, no worries. Yeah. So I'll just quickly mention that the projects, that there's two different types of projects, right? So if your background is software development and that's the area that you want to focus, then the projects in the list on this website are flagged as either software development or R&D. So if you want to get into the code, if that is something that you're interested in, then take a look at those projects that are flagged as software development type projects. But also we realize that, software development isn't for everyone. And, some people just want to use the software as is, but there's a whole bunch of R&D that could be conducted with the tool as it is, as it stands right now, because there's, from wake floss modeling to wind flow modeling, there are, different sensitivity analyses that we can conduct using the software as is. So don't be intimidated by this if software development is not your background. Again, if you just want to do some research, and it can be fairly simple, it can be fairly complex. In fact, if you are a student or if you're a professor and there are some students looking for a project to focus their thesis around, this is an area that could really help, spur some ideas or, define a project thesis that could be, again, just focused on R&D. If you don't want to get into the code, totally fine. There's lots of stuff to do. And Erin and I are, really want to encourage that, and we'll support that effort, answer questions, and help guide you in those R&D projects. So wanted to give that plug. We're excited to see this growing community. It's amazing. It's our third session, and we had 50 people RSVP. We're growing this community, and it's great to see people from all over the world attending here today. From India to South Africa, Vietnam, all over the place. It's really fantastic. So we want to keep it up and keep building this community. Okay, well, that concludes the content that we have to share with you today. I really hope that the exposure lecture series was interesting, that it was helpful, and again, the intent was to wrap your head around that concept before we get into the wind flow model algorithm and derivation. It's a core concept to understand. We hope that it was communicated clearly. We'll be posting this video of the town hall, and we'll also post the PowerPoint if you want to review in more detail. And again, I highly encourage you, whenever you're looking at a new site, go directly, after you import your data, go directly to that Met and Turbine Summary tab, and you'll be able to learn a whole lot about the site that you're looking at. So yeah, I encourage you to do that. So we do have a few minutes, so we can open it up to any questions and or any comments, or maybe even issues that you've encountered. We're happy to discuss those here. Appreciate that feedback. Thank you so much. I feel like we should have some elevator music to play during the open Q&A session or portion. Nasai, sure, we can connect after this call, certainly. Yeah, Erin and I are in the same room, so we can hop on a call. It is lunchtime here, but no, we can stick around and chat with you about what you're doing in India. I'd love to learn more about Acme, I believe is the company you're with. So yeah, I'd love to learn more about what you guys are up to and your experience with the software so far and anything else that comes up. Jack Klein, that means a whole lot coming from you. I really appreciate that.
You're welcome, Liz. Y'all did a great job there. Exposure is not a simple concept to explain and clarify, but I thought your stepwise approach was very cogent and on point. So well done, both of you.
That means a lot. Thank you so much. Yeah, I know when I was first introduced to the concept of terrain exposure, it took me a while to wrap my head around it, about the whole upwind to downwind. And now, fast forward 15 years, it's second nature. But when we explain it to someone new, it's always a bit of a challenge. So really appreciate that feedback, Jack. Thank you.
My pleasure. Well done.
Thank you. Okay. We can definitely end early. Yeah. We have some folks here in Ohio. They're probably excited for our lunch. Oh, there's one more. Yeah, so here's our final slide here with our contact info. So I did post my email address in the chat, but Erin's is also up there. Very simple, just Liz or Erin at One Power. So comments, questions, we're always, more than happy and willing to answer those. And Yeah, as I mentioned, we're both here in Ohio. We talk a lot about Continuum on these town halls, but we actually both work, Erin and I, for one power company. I mentioned we're at the headquarters here in Findlay, and yeah, Continuum is part of our wind resource assessment core tools that we use. So when we're evaluating new sites, we use Continuum for wind resource assessment as well as site suitability and all the other tools. So we not only are the developers and product manager of the software, but we also use it on a regular basis. So just a little bit of a background on that, a little plug for one power company. Okay, well, if there aren't any other questions, we'll adjourn early and we can go talk to Nath Sai. I'll be happy to chat with you for a few. And we'll be holding another one of these in 2 months. So stay tuned for that, and stay tuned for the new release 1.3.2. Again, I'll send an email to this group, as well as posting it on LinkedIn and on the website. So till then, take care, everyone. Thank you so much for joining. Really appreciate your time today, and we hope to hear from you.